or I think they call it Mapathon. I used to run it, but I'm too busy. But what they'll do is OpenStreetMap is like a crowdsourced mapping data set, and you're not allowed to steal it. Like you're not allowed to use it without giving back to it. So like Google or Apple can't just take it. And this is actually how Waze routes you. So they can use it, but they sell you Burger King ads. They don't sell you maps. But then they contribute back to building out this data set. But some of the things that happen in the zoo, a lot of this stuff gets mapped out. I know we did Cherokee Street at one point, and I'm pretty sure we got, I can never remember where Cherokee's at. Somebody remind me. Oh, right here. On this mapathon, you'll go and submit edits, and so people will walk around and add these businesses, and you'll see like there's little trash can icons. So every trash can has been put in, and if you click on like, I'm not in editor mode, but this is how like something like Waze gets built out and just only gets better over time. You can do anything you want, but most people are good, so it eventually gets revised or removed. I think you do have to get it approved, but once you do like so many like approved edits, then you can do as much as you want. So yeah, that's a fun like neat introduction to, I guess, some getting involved in some mapping. And by the way, like this, you go overseas, this stuff blows away like Google Maps or Apple Maps. Like they're all great here. We make fun of Apple Maps, but in Europe, Africa, these are fully have all the vectors and that added to it. But Google hasn't. Google's method is drive a car. They're not going to fly a car over there and drive it around. So this is like a really cool project that's been going on for at least a decade now. So my talk, or I guess everything I'm going through, will be on GitHub. Tetris code. There are no cheats or codes with Tetris. I thought that was funny in '06. I haven't been able to switch away from it. So if you go to that, you'll be able to find the full stack PostGIS talk. And that's what I'll go off of tonight. And if we come up with any other links that we come across, then I'll add them to here, resubmit the slides tonight or tomorrow morning, and then you'll be able to see what we talked about and run through the examples. So I guess first off, who considers himself a developer? All right. Who wants to be a developer? Okay. Who's got experience with databases? Okay. Does anybody have no idea what a database is? Maybe? Okay, so we're going to go over some mapping data. All this data is going to be written to a hard drive in a very, very efficient manner. If it loses power, like if you're typing an email or typing something in Facebook, your computer shuts off, you lose all that. A database's job is to be what's usually called durable, where the data that's written can survive power failure or certain types of corruption, and do backups and things like that. So it's basically got a sole focus of storing and querying data. So who else use Postgres? Okay, or MySQL? Okay, so Postgres is kind of taken like 20 years to get popular. You can now use it on things like Amazon Web Services or Google Cloud. Some of the smaller providers like DigitalOcean, you can go and for $5 a month have them run an instance of Postgres for you, and you don't have to do anything. You do have to watch it because you can rack up these bills. You pay for what you use. But one of the neat things about Postgres is that you can extend it in certain fashions. And what I'm going to go over tonight is PostGIS, so Geographic Information System. I never remember that. But what this is basically, it gives the database the capability to store data that's found on the Earth. It's put it in a simple term. So all that OpenStreetMap data could be stored in Postgres. So you could download all that data, run it on your laptop. It's going to get really, really hot, but you can copy that data set, serve it out with something like Postgres, and start doing things like, where is the nearest trash can to my location? So mapping type of things. And so does anybody have no idea what GIS is? Okay, so I guess a good example of, so like both like political parties will criticize each other. I didn't think I was going to go here this soon, but they'll say, oh, they're busing people to the area. Well, how do they know? They're not busing every person in the US to an area. They're doing analysis, finding out what county, what road, through all these things called like spatial data analysis, using tools like PostGIS to find out where is somebody really, really likely, because it's expensive to send a bus and I need to swing this county or this district. Let me use these techniques to find out where to drive. So if you say that's cheating, well, it's actually really smart to do that. And that's driven a lot of the, like, elections and things like that have, while there's a lot of like redistricting that's really, really bad, that's the good and the positive of tools like this, is that you can run scenarios or do analysis based on, portions of the Earth, compare them, and then make a decision off of it. So let me run through. Okay, so went through the PostGIS homepage. I'll have links here. You can download an app for Windows or Mac, and I'll show you the Mac one. It just starts up this little elephant. You can open it, and I'll do it with a nice interface on top of it. But that's what I'm going to do tonight might look a little daunting. This is a really easy way to get started with that. And so I'll have the Windows and Mac links in the notes. And if you're running Linux, you're on your own. You can figure that out. Okay, so what about, everybody know what JSON is? Okay, anybody know what GeoJSON is? Okay, so it is basically special JSON that make me remember this. Actually, I'll show you how to make it. You can add a point. And so what this is this is valid JSON that will describe points, lines, polygons. And this tool is pretty good for generating sample data, test data. And so you'll see here polygon, top left, top right, bottom left, top left. So it'll give the points there. And then you can also draw, things that are a little more complex, and it will show it. And so I'll do everything tonight in JSON, and we can paste it into this web page. It's called geojson.io. You can also save your data. So yeah, I guess a neat thing is you can, if you paste this in GitHub or a lot of your source code tracking software, GitHub will display a map instead of actually showing this data. So you can download it, KML, which is going to load up in Google Earth. So if I wanted to author a KML file to load up in Google Earth, I can then, tap that, have it load up. So next. So people know what Docker is pretty well? Okay, so I have a little, and this will be again in the notes, so don't feel like you're missing out on it. I have a little PostGIS image that's going to run on my machine. And then there's this tool called PG Web that will connect to it, and we'll be able to run queries against a local instance. So, okay. Is it working? Okay. So since PostGIS does not come with Postgres, you have to add it. And so the way to add it, let me go ahead and get rid of this, is to run this create extension command. And so what this little Postgres tool says, connect to my instance, to my full stack database, and create an extension called PostGIS. And so this should all work. If it doesn't, I'm not going to be too worried about it because then we can work through it together.
So if I'm running multiple databases on that Postgres server, if I want it, that PostGIS would just apply to that full stack database, I'd have to run that again?
Actually, it'll get applied to the instance. Or no, you're right. Just that one database, yeah. So yeah, it is opt-in on that when I specify. The database I named is called full stack. So, all right, so now we have PostGIS extension. You can't tell because it runs successfully and it's waiting for you to do something with it. So first thing we want to do is create a table. And I will run through this here. Okay, so first thing we're doing is create table, name points. Let's make an ID. Serial is just going to start with 1 and keep incrementing each time you add a row. I'll give a name column. And so then here I've created the points database, or the points table. So I look at the structure. You'll see it's just exactly what we added. Now if I go in, I want to add a geometry column to this. So oh, hold on. I remember my syntax. This is called PG Web. So if you ever use like PG Admin, it's a little nicer version. So let me start this over. There's a syntax where you can go and add a geometry column to an existing table. You can, there's this really cool cheat sheet. I won't spend time trying to go through it, but this has all these functions, and I'll work through some of these in a scenario. But this little cheat sheet of, you know, rotate something by this amount, or what is the outer boundary, like an envelope of the points. All these functions are here for you to look up that are available to run once you've added the PostGIS extension. So here I can say geography, and you do have to give the type of point that you want to, or the type of feature. So line, polygon, point. Uh-oh. I don't think I'm in my database. Okay, so it's saying that I don't have the extension loaded. Extension PostGIS already exists. Maybe this will be a short presentation. Yeah. Yeah, I'm in the full stack database here. Let me make sure I didn't skip a step here. Oh, okay. I'll fix my notes here. What I didn't do was create a user for the database. Okay. Now it should work. Does anybody feel my pain? All right. Not sure why this app isn't working. All right, let me try this.
Are the default permissions like all admin or whatever? Or you have to say roles or whatever?
Yeah, you do. Like, I don't get to do this at my job. So somebody else is in charge of making sure this doesn't get screwed up. Obvious, for good reason here. So like I get permissions to connect. Let's see. Let's see if this works this time. Actually, do I still have that Postgres running? Here, let me try restarting this. Okay, I think it'll work in here. So, first thing we want to do,
Maybe shrink your window because we can't see the bottom line there exactly.
okay. All right, so that finally created the table. Why is it not letting me connect here? All right, here, I'll switch these up. All right, so it did create the table, and now I can describe the table with, this now has a geography in it. So, a little bummed that's not working. Let me try it one last time. All right, not going to work. Okay, can everybody see this okay? All right. So, let me try this. All right. Okay, so we have a table that's called points and this geography thing. So there's two things you can do, geometry or geography. So geography is, it basically views the world like it can be, like it's a sphere. I'll show this real quick. Or a flat Earth, which has kind of come back in popularity lately. But you'll see like things like Greenland, New Zealand look giant compared to what they are compared to Africa, which Russia is like really, like going back many, many years, really likes the way our maps look because they get stretched into look like this giant landmass. And so, again, that's like easy to see, but this is the actual like comparisons when you, if you actually measured, you know, what is the actual square footage. So I'll just let this run through. It kind of speaks for itself. And a lot of times this doesn't matter. Like if I'm finding out like I've checked in at this location, that's not necessarily a big deal. If I'm building a shopping mall, then this skew that happens actually does matter. If I'm, as you imagine, firing a missile, this matters. So like the shape of the Earth, flying a plane, the actual shape of the Earth and how it actually happens is, or how it actually is, very important on certain things. Google Maps, you saw I put 4326 in there. That's what this yeah. That's one that always gets me. So, no, I get the YouTube ad. And so Google for kind of like computer science reasons, you saw me put 4326 in there. If you look at this, what's called this like European Petroleum Survey Group code, that 90913 is Google. Like if you wrote Google with numbers, that's what it would be. So they came up with their own like map projection called Web Mercator, and they cared more about serving maps fast to people than the world looking right, or basically prioritizing that. The one we're using is 4326. In my like 10, 15 years doing this, I just always type 4326. Some people get really, really mad about these. But this is basically saying like in 1984, NGA or somebody measured the world and came up with like how it actually, it looks like a really weird peanut if you actually looked at like the Earth minus like water and clouds and all that. But this is kind of the accurate way to go. And so PostgreSQL, things like MySQL have the ability to do mapping and stuff like that. PostgreSQL handles all this for you. So if you just put these values in and then you start saying like, is it within this polygon? The math has been beat to death for like 30 years. So you can I've told you enough to use it. If you start veering off of this, now you need to know what you're doing. Like if you think something is in England, but it's really not, you're going to have to start thinking of things like that. If you, draw something in Google Maps and then go back and translate it to like a sphere, you're going to start having like inconsistencies with how things look. Driving directions, looking at, what states what, none of that really, that's not really what this is for. This is for like high accuracy mapping, and you get that for free with something like PostgreSQL. So, first thing, insert a point. Okay, so insert into, let's put it in the right table name. Our table is called points3. Okay. So now we've inserted a point, but it's in this really weird format. Is anybody like totally confused by this, or it seems like very esoteric? All right, yeah, it is. So another example is you can state this number that I told you not to mess with when you're using it. I think that's We don't need to bother with that. But you can take a point that was in one format and then reconvert it. So if I took something in that like Google number that's a different coordinate system, I could insert it into my table that's the 4326 I told you to use. So what's our column? So now we have, like, how do we get, when we retrieve this, how do we actually get this to be something human readable? So now here, this will, you know, ST as GeoJSON. I have in a link I have in the bottom of the page here is a list to this cheat sheet. So if I go to ST as GeoJSON, returns the geometry as a GeoJSON element. So if you're doing any Node.js, Python, pretty much anything, just use this, and then you can use any regular JSON parser. If it's JavaScript or Node.js, you don't need to do anything. It's already invalid JavaScript. So taking that, we can take that and paste it into here, and right off the Horn of Africa should have our point. By the way, this is called Null Island. So if you ever hear that term, just 0, 0. You'll see a lot of like people's software that has like, you pan over and there's like thousands of points because they've messed up on the geometry and it just all defaults to 0. So we can fetch data. If you want to do it as KML, so if I want to, you know, write it out as a file, you know, you switch this little function, and it'll put it out as valid KML. So let me see if I can.
What's the ST stand for in those?
That's a good question. Usually when you add an extension to Postgres, you add those little functions. It's probably spatiotemporal. But I don't, it might be somebody's initials from like the 80s. I don't really know. Right. So we should be able to.
It's basically a namespace, prevent namespace collision.
Yeah. Yeah, and there's all sorts of extensions that people have come up with. I mean, people have launched many businesses around adding extensions to Postgres. So Google has one. Everybody's got their own little problem they like to solve with it. There's actually a neat one where you can add JavaScript in there, and so you could actually, where I wrote ST as GeoJSON, write JavaScript, take the data, it'll execute the JavaScript code, and then send you back whatever you did with it. So if I add like the letter F to the end of everything, it could return that.
I wasn't sure if it represented like that format that you showed with all those numbers.
No, not at all. What that's actually called, that number is actually called, that's WKB, called well-known binary. Did I spell it right? Oh, here we go. Yeah, as binary returns well-known binary. Extended well-known binary is, it will send you back the projection, or it's supposed to. But that's usually how, like, when humans aren't reading it, how it's transmitted. And then also it supports 3D. but we have to create a table that lets you do 3D. So point is just XY. So let's make a table called points 3D. You'll put the word Z or the letter Z in point, and then that'll give it a Z value. And so then now I can make this bigger again. Hide this one.
Is the 1, 2 lat long or
Thousand as
Is the what?
is the 1, 2 lat long or something, or rounded, or?
Yeah, sorry. X, Y, Z. So easting, northing. So X is east-west. The next one, Y, is north-south. And it's actually longitude, latitude. Like Google's the only one that does lat long. Like we say it, we're taught that like in third grade to say it in that order, but everybody else does X, Y, long lat. And if you think of like Y, latitude is a ladder. So it's these lines that go this way, and it measures how high up it is. So, but usually X, Y, Z is the order. Oh yeah. Don't ever do projections.
But that's just 1 degrees, longitude, whatever, the 1?
Yes. So I think St. Louis is negative 3889. No, that's way too high. Yeah. So 38, negative 90. So negative 90, then 38, and we'll say 3 of elevation.
So what's 3 meters?
Yeah, it's called height above ellipsoid. So the sphere is an ellipsoid, and like an ellipse is like an egg. An ellipsoid is like is a 3D egg, and so that ugly peanut. Let me show you. You can just call it elevation. Let's see if we got an image. Yeah, here's a good. This red line is the model, and then there's some math that'll happen that will actually convert that to like the blue surface of the Earth. This is all like stuff you don't even want to. It's not that. Very few people come across like needing to know this type of stuff.
Is it the same concept as sea level, or are those two separate?
Yes. Yeah. So height above ellipsoid this is basically layman's term for sea level.
Okay.
But it's probably not. There's there's not really sea level.
Yeah.
So like for example, everybody thinks that the magnet goes north. But you actually have these, like it's weird, we're in St. Louis and like this green line is perfectly straight up and down. If you took a magnet other places, it would go all over the place. So you have to, like I know the Android phones actually get, you can look on like the Android developer site, it'll say like, we get our magnetometer data from NGA down the road. So somebody produces this just like that ellipsoid, but we don't even, north is like down the road from what this actual model is. Like we just get pointed in a direction. We don't have to worry about all the details of how it's actually made.
So if I had a compass over in Russia, what would happen?
It would bounce. It would measure that way. It would get you close. If you had a phone, it would account for that.
Oh,
Yeah.
the coordinates or whatever, and
Yeah, and I don't think that really. I don't know how well that actually works. I've never asked like a scientist like do you use those? So
Isn't that gonna flip around like in 100,000 years or something too?
I think if it flips like solar, like there's some weird. There's a lot of people that study that. I mean, if it does flip, there's something like magma will shoot out like some. They know what'll happen if it flips. So I don't know if they know what they're going to do about it, but so here we have. We'll go points 3D. Now has this elevation since we are storing it as that. GeoJSON. And so here we can take that output again, put it in a GeoJSON IO, and if we click on, well, okay, a little off, but fairly close. Most people in my field have this up at all times. So like if something doesn't work, paste it in here, visually look at it, trying to figure it out. Okay, so we put it in 3D. This better work or I'm gonna be bummed. So now let's load some actual data in here. So there's this tool called OGR to OGR. People call it ogre to ogre. But it'll take one format, convert it to another. So here we'll take GeoJSON of the 50 states. Let that chew. GeoJSON outlines of the 50 states, and then we'll load that into PostGIS. So here is, let's see, what. So here's Maine, and there's the polygon that represents Maine. So here we'll take, and again, this is all, you can go into your, you use the notes and paste in these commands. But this OGR to OGR will take the state's GeoJSON and we'll put it into a table called states. Okay, very fast. Okay. So here we have a new table called states. And so if we look at states, it basically just took all of the fields that are in that file. So like I said, this tool's like, these are like 30 years old, so they're pretty smart about how they handle this data. But it created these as multi-polygons. Why is it a multi-polygon? Missouri's a polygon, but it can be represented as a multi-polygon that has one polygon. Hawaii is a multi-polygon made up of many polygons. So there's things like multi-point, multi-line string, all it means is all these line strings are all together as represented as one feature. So we've loaded in the states, and now we can, actually let me get my query. Actually, let me adjust some more data. So I've also got something called capitals.
And where are you getting this data from?
If you, I just Googled for state capital GeoJSON, and somebody will have it. You know, there's dozens of them out there. And actually, data.gov, which is like a new, probably like an 8-year-old, 10-year-old effort, was an effort to basically put a lot of public data available in these formats. So it's usually all mostly really, really boring. Like it's so much data, and it's not really clean. It's what you'd expect from people that don't have enough time to like clean, you know, put out these nice data sets. But it's definitely a huge step in the right direction as far as like getting access to data to start doing things with it. So let's look at, I'm not thrilled that this is not working. Try one more time. All right. Okay, so let's just get just a couple items back. So let's bring back state abbreviation. Let's do that. Okay, so Wyoming, Pennsylvania. Now what I want to do is put state capitals in there. Oh, wait. Let me look what's inside this data. Open capitals. Just pick out a couple fields. Okay, we'll do state and name. So I think it's select. So out of those properties on the data, you can pick what you want to keep from it. And we'll just keep name out of the properties. Oh, I'm missing. What's that? Is it what? The way it's doing like the nice autocomplete in that, or it's called Fish. Well, this is the terminal is called iTerm, but like the auto completion is this little program called Fish. I got something. I typed something wrong here. Oh, I can't name the table the same thing as the file. Okay. All right. So now we have a table called capitals. So there's all 50 capitals. And then we also have their geometry. So it named the table WKB geometry, or the column that has the geodata in it is called WKB geometry. So let me do something. Sorry if this gets a little dark. I was looking for a large data set, and there's actually collisions with people and cars in New York, and it is a lot. And they have the borough, the person injured, the pedestrian injured, the person killed, or the pedestrian killed. So this is 26,000 incidents, I think. We'll find out here. Collision. Yeah, 26,554 incidents. And so if we look at what's in the data, it'll actually say, there was a wreck here in Queens, one person injured, one pedestrian injured, no people killed, no pedestrians killed. So some use cases is that I've loaded data into several different tables, and nobody would ever do this. This is kind of corny, but let's find, let's see. You know what? Let me re-import the state data. You can list the properties. So like I want name, and I didn't include state. And so I can do name and state. What's going on? Okay. So now I should have capitals. Yeah, I'll have state in there now. So here we want to, let's find what is the capital of New York and where is it located? So here,
Albany is the capital of New York.
anybody wants to buy that, you can have it. So here's the data. And like I said, what I'm about to do really doesn't make any sense, but just trying to prove a point, and what you can do with PostGIS. So I want to find the borough and the number of people injured. Where I want to look up what is the capital, what is the location of the capital where the state is New York. So give me that geometry. And then this doesn't make any sense at all. But if you kind of like squint, it looks like how far are these two apart? So if you go to the cheat sheet, and I don't even try to remember this stuff. Search for it, you'll see this returns the distance between 2 points. So you can also do, 9 times out of 10, I do ST distance. So pass in 2 points, what is the distance between those two? And save that value as dist in meters. And then, select borough, person injured. From the collision table, where person injured is greater than 0. And then order by the distance between them. So give me the closest accident where a person was injured. So if you know your New York geography, Bronx is way north. And it's going to sort them based on that. And so now if I say, give me the top 5, it will then do that.
But so these are the closest accidents where a pedestrian was injured, closest to the capital of New York?
Yes. So again, Albany is nowhere close. Yeah. So like I said, there's just like two data sets I could find. But that's kind of a simple like sample of something you could do. And then
So that's saying 1.75 meters?
it's actually 1,000 meters. So actually no, it's off. 1,000 kilometers, I believe. Yeah, right? Isn't that about 80 miles? And the data could be wrong. So, so then that's the n closest. Well, let's say I want to come up with how many are within a certain distance. So let me paste this again. And so this one gets a little more complex. Does anybody ever, does this look totally foreign to anybody? Is everybody, okay. This is like a rite of passage to have to put up with this. What this is called is is a join. And sometimes you say, I have a table of people, I have a table of counties, join, and I have a county ID where each person lives. Join that county ID against this list of counties, and then give me back the person in the county. So I'm joining 2 tables in order to make one, because you want to basically, you'll find disputes on this, but you basically want to, logically separate your data sets into types. There are databases that do the exact opposite of that and try to target a different audience. So for example, like I brought up the election. They would never use something like this, it could be way too slow. They'll use something that bunches it all together because they know they're not gonna be doing, they know that they're gonna be doing these giant queries on the data. So a voter and a county, those will never be separated. That's the only thing they care about. So put them together so the computer doesn't have to go through the work of putting them back in. So here I say, give me the borough, the distance between C which is the collision, ref, which is the geometry. I actually just learned last night you could do that. You could just call this R and do R dot geometry. But select those from the collision table where, or give me the geometry, and the distance between the collision and the capital where the state is equal to New York. Call that the geometry. But I want it to be within 1,000 kilometers. And then I want you to order them by distance. So if you do that, obviously that number is well within. But now if I say, here, I'm going to get no rows back. If I say 1.76167, sorry, this would be a lot easier if that other program worked. So here I'll have everything within 1.75. If I limit it to, if I play with that distance. So you'll see that increases as it goes up. So obviously you would do, a Google Maps example. I'm here, show me where restaurant equals coffee shop within 300 meters of my current location. So these are the kind of systems that pull off those type of queries. And you should be able to get millions, tens of millions of point data and have this handle it pretty easily. So another one is covers. So I'm just going through a few of these functions that are kind of common use cases. So show me how many collisions from collisions where the geometry of the state capital of Missouri covers the collision. So only show me things where the Missouri polygon covers collisions in our collisions table. And so if you guessed 0, then you guessed right. If I switch this to NY, then it will be all of them. And then we'll do, okay, so those are just like, is this true, is this not? With these functions, you can generate a lot more, you can do a lot more with the data once it's loaded in there. So there is something called a Delaunay triangulation, and it's very popular in things like video games. How can I output this? Let's see. Oh no. Hold on, I'm gonna have to Google for this because I'm about to. I want to show you what this is generating, and it's generating something far too big. Does anybody know how to output to a file?
I think it was dash scroll down or something.
Yeah, you're right. Great. Okay, that works. Okay, so here we have GeoJSON, which is a triangulation of Missouri. And so does anybody know what triangulation is, really? I'll give you a visual example. Take a second. Okay, so it's basically like breaking a polygon up into triangles. The more complex things get, the more triangles it uses. So things like video games over the years, you may hear like an Apple keynote how many triangles they can draw in a second. And so a lot of these things are generated as little tiny triangles. And when they test for like, where did I touch, it's easier to like traverse these triangles as opposed to like load up all of the Missouri polygon. Because I can say, are you inside these 3 lines? Yes. Very fast. Versus load up all of Missouri. What you do is you make this triangle, and then you can test, yes, it was in Missouri because it was in one of these triangles. So you basically pre-compute. And so that's how like things like, something's flying through an air at an alien in a video game. It's testing for, did this one set of triangles hit this other triangle? Which is how they're pulling that off. And over the years, they've gotten better and faster at just drawing more and more triangles faster. And so those are all sorts of those functions that exist that are something like a convex hole. If I put nails into a wall and made it in the shape of Missouri and then stretched the rubber band around it, where that rubber band outlined would be the hull of that. So it's going to take your outermost point and draw a polygon. Why would you want to do that? If I want to check really fast if a point is in Hawaii, first I'm going to check, is it in the hull? If it is, then I'll proceed and check all the islands. And so these are tools that are like fast ways to throw out, are points inside this polygon, are they not? And all these are in here. Let me see if I can do. Does anybody have any questions at the moment? Almost finished here.
I've got one that is kind of more high level, so I'll wait till this is
Okay. So here I did a buffer around Missouri. And so what this does is I buffered by 1, so I'm going to buffer by a degree of latitude and longitude in every direction. And so, do I really need every single point on Missouri to tell that's Missouri? Probably not. So I can simplify these things, make them smaller. And you'll notice this was much, much smaller than that triangulation or the other ones. So there's a lot of things around line simplification. Actually, I have a function for that. Okay, so here is a simplify Missouri, or simplify the geometry where state equals Missouri.
But you're still reading the original data,
Still reading the original what?
the original data for the state,
Yeah.
and then playing that function on top of that.
Yeah.
Do you not extrapolate that and stick it in a different table or something, or is it fine to read all that?
That's a technique that can, if this was too slow, then yeah, I would do that. If it's fast enough, then I'll just store it in its original form, and then I can create other data sets or simpler forms of that data if performance starts becoming an issue. And so there I took simplification from 0.2 to 1, and now there's this algorithm that's a line smoothing algorithm that it's running. It's gonna basically take like every few vertexes and just make them 1. Last thing I wanted to do was so let's do collision. So this whole time this has kind of been storing it in a very naive way. Oh, craps. I should have did that before. So I should have ran this query before I made the index on the table. Actually, I can do that. It might not be enough data to actually matter. As crazy as that sounds with 26,000. Okay. Yeah, it might not be enough data. Actually, yeah, it's probably not. So what I was going to show you was is anybody familiar with trees, like trees and databases? So this used to be the way it was stored. It's not anymore. Now Postgres has these thing called generalized indexes that are better than this, but it took 15 years, 10 years to get there, I think. But so the tree that stores the spatial data is called an R tree. And so basically let's say I've got all the capitals and I don't want to search through every capital and find them. it would be better to say, imagine these shapes are capitals. Am I within R1, which is my very first box I'm going to test? Yes, you are. Okay. Am I in R3 through R, which am I in, R3, R4, or R5? And so you'll see that R1 contains R3, 4, and 5. R3 contains 8, 9, and 10. And so let's say I'm trying to figure out where is D3 at. I'm going to, or better way, what is, let's say I'm right here. What is the closest feature to me? And so I would say, okay, I'm in R1 in this box. Now I'm in R3 and R4. I'll test both of those. And then I'll test, but I won't test R5. So R5 is over here. So it's splitting up the data into these regions. And the less overlap you have, the better. So if everything overlapped, I'd have to test everything. Unfortunately, R4 and R3 overlap, so I'm going to have to test both of them. If I was right here, I would just be in R3, and I would test 8, 9, and 10. Well, there's only one thing in 8, and so the closest one is 8. And so this is kind of a 3D visualization. So you're always in the red box. And then let's say I'm wanting to be this point here. You're going to test these outer boxes and then drill down in 3D space. But the point is that, well, all the stuff we were doing without having an index on that was testing every single point all the time. And if you have enough data, that will create problems.
So what kind of index was that you showed us?
So this is called an R star tree.
How does that relate to the gist?
I don't even know. The gin is like this magical index that outperforms all these. And a lot of this stuff is like a lot of arguments are why don't we just use PostgreSQL? Why are we using something fancy that's new, that's not proven, when it's had this much time, spent to go over it. So
So to create an R tree index, what would be your, is it create, it's not just create index, it's create what kind of index?
I will, let me see, as C. Actually, you know what? I can rerun that within query. Let's see. Let's try this one. Sorry, I wanted to do the n closest within a distance. So something like this, where you're actually trying to test like relations between each other. So I really wish I had that. I'll fix that app and I'll have a walkthrough how you can just use it. Because it's a little painful typing all this out every time. So when you put explain analyze in front of it, it's actually going to tell you what the database is doing. And it's going to say, first thing I'm doing is I'm sorting on I'm doing the distance. Then I'm running quicksort, which is like a text sorting algorithm. And then this here, like sequence scan on capitals. Anytime you see sequence scan, it is scanning all of the table. And so if we do, so you asked how to create the index.
Oh, you don't get to use this.
Yeah, and so if I say create index geo on collision, the collision table using gist, and index the WKB geometry, and let's see, actual time. This may not be enough,
Yeah, it's not enough data.
which is kind of crazy, but that's kind of how you solve these problems of, you add indexes to the data. That does slow down how quickly you can import data, but it is a, let's see. Using state. Oh wait, what's our state table? Capitals. So you can add, like I want to index the states. So if I'm looking through the states trying to find where it equals NY, don't check Z, don't check things that begin with A. I can't remember the latest, or how do you? There we go. So that's how you do it for a non-geo column. So yeah, that's basically it. I'm sure that was probably a little boring watching me fumble through some of it. But hopefully you can take this and use this as like a little primer for, adding data in. If you have an app you're developing and you want to put some foundational data in there, you'll probably be shocked at how much data there is out there in these GeoJSON. And a good one to search for is shapefile. So here we go. The OpenStreetMap data set is here. You can download the entire continent of Africa. These are absolutely giant files. And this is all zipped and compressed. But if you just want a certain country, you can go into North America, and then I can say, okay, Missouri's 94 megs. Get me this as a shapefile. And then you can, I won't kill everybody's internet who's working. You can use that Ogre tool or other tools to load up shapefiles. But you'll find lots of shapefiles around on the internet. I think uncompressed, this is like 800 gigs of data. And
So do they just have like usually one kind of feature in there, and like for all the bars and restaurants, you have to load a different file in? Or?
oh no, it's all, that whole state is in there. Yeah, yeah,
And people are constantly adding to that?
yeah.
You store that just in your
And
local
storage
database.
flows and do all those?
Yeah, that's usually a good test of like a database is how quickly can you import this data. So something like Elasticsearch will say like we can ingest all this data in like 3 hours. And they'll use that as like use cases to present to customers of how fast can we do this? And people who've wrote it, there's an extension called like Green Plum to Postgres, which is like a big supported version of Postgres when you want to run like hundreds of servers or like crunchy. They'll say like, oh, we can do the entire OpenStreetMap corpus in X amount of time. Or sometimes people will say, we can even do it at all. Like that's enough of an achievement to run this. So
So then once you have it in Postgres, there are updates being made to OpenStreetMap. I mean, does it matter if you want to get the latest, freshest version of OpenStreetMap, you just import it all again?
no, you can get the deltas, and that's what people will do is they'll do it they'll pay the penalty once, and then they'll listen on the deltas.
Do those include uniques?
No, it's only latest. So are you asking will a delta remove? Yeah, it will. It'll say what they got rid of, and I think if you
Because 80% of the restaurants have to go away the first time.
yeah. So and there's this is like a pretty incredible data set.
I was curious if you could do that PostGIS on Amazon's RDS for like Postgres RDS.
Yeah,
So it looks like you can add that.
you can. Yeah, it's in there. So like this is Cobble, and like there is, I don't know who. Actually, you can actually find out like who if you go into edit mode.
Who contributed it?
Yeah, you can find out who was the person who added that feature. And so, I could say, how many levels are in this building if I was on site? So yeah, I don't know. This is basically a bunch of, you can donate to help serve the data out that hosts this website. And I'm pretty sure it's in Postgres. Actually, it is in Postgres. But like you have to like prove your Postgres has got enough horsepower. Usually if you see things with the word OSM in it, OpenStreetMap, that's you'll find. And so there's this OSM to PostgreSQL. And then there's an extension called PG routing. So you can do create extension PG routing and do drive-in directions in Postgres. And so that's where this OSM to PG routing is, take that data set and then route me on the roads that are there. That's an incredibly hard problem because it used to be like 5 years ago, if you use it, you'd be driving down 270 and it would say, get off on this off ramp and then get back on the on ramp because you won't have to drive that entire curve. You'll like shortcut. So it's really, I think I looked at that like probably 5, 6 years ago. Whereas like Google Maps is like, stay in the third lane from the right. Like just to have that amount of data is insane. Now they did buy Waze, and some people are mad about that because they think they're stealing Waze's traffic data. And people argue, you can't generate data off this without contributing it back. So
The routing, did you say that was a separate plugin?
yeah, it's called PG routing.
Okay. And that just uses, it doesn't actually use like time data, historical traffic patterns or things like that. It's just geographic data.
Traffic is a whole other ball of wax. There's quite a bit of like what's the cost to go down this road. A lot of that stuff's been added. Because it used to be, there was a difference between an interstate and an alley. And if you look at these kind of problems, you'll realize that if you're on your GPS, you say I can get there. I know better than the GPS. You probably do. Like, they're not exhaustively checking every single route. They're just doing good enough to where you keep buying the unit, or better than Apple Maps. Like, that's like the bar. The actual real answer is way too expensive to find out. And while as awesome as Postgres is, like, there's a reason that, or as awesome as like OpenStreetMap is, there's a reason that like TomTom and Navtech are still getting paid lots of money for that road data set. And why things just never improve in certain areas, like rural areas never get updated by Apple Maps, or not nearly often enough. So. Yeah, any other questions? Oh, does anybody, people do Python, Node? So, and I can add these as links. If you do Python, SQL Alchemy, there's something called GeoAlchemy. All these tools have Python bindings. So if you look at libraries like called Shapely, Fiona, GeoAlchemy, you can write code in Python and not have to do what I did, in the terminal. Node.js is there's not really a lot of geo stuff in there, but you can just if you write the query and say like as GeoJSON, that's good enough. Java, there's tons of things like GeoTools and that can connect to Postgres, and then I don't know if anybody's doing Go, but that's like a step back in time. So you have to resolve this problem for that. But yeah, that's all I have. And I'll update these notes. I will get that web app working, so you can put them in there, and it's much nicer because every time you run a query, it'll tell you how long it took. So I'll get that fixed, and then I guess you can send it out to the group, right? Okay. So yeah. Yeah. Wow, I talked for a long time. Thank you. Sorry, I thought that was an hour.